Hey, welcome. This is the part 2 video of GPT-3 explained series. There will be more GPT-3 related videos to be released in the future. And today we are going to learn what a language model is and how you can use it to boost your NLP systems by quite a lot of margin. To be honest, most of state-of-the-art NLP systems are built on top of a language model. Why? Because the language model already pre-trained, already seen a lot of English text, so it has a certain capability of understand English or whatever language you are working on. So that using that can increase your model's data efficiency a lot. That's very important. And there will be more deep learning videos be released in this channel too. So if you would like to receive them, make sure you subscribe so you can receive the notification in the first place. So let's dive in. So what is a language model? Language model is basically the way to model a probability distribution over a sequence of words. And you can use statistical models or neural network models to learn from human generated data. Basically, it's text, or a lot of documents they created by humans to learn this kind of a probability distribution. And we usually use the self-supervised way, or some people call it unsupervised way, to lay the neural network model to learn that. And the typical way to learn a language model is to do the next word prediction. So basically, is to give you context previous words, and you need to the neural network model needs to predict the next word. For example, in this sentence, I always go to that restaurant to have my favorite ice. The correct answer probably is ice cream. And definitely there's also other words they will be correct in this context, but there will be the probability distribution. The most probable word for this probably is ice cream, right? So the language model needs to model this kind of probability distribution, and the training objective is to predict the next word as accurate as possible. So you will have a lot of examples that you extracted from your training data like this, a lot of different sentences. Then you need to use the given context word to predict the next word. And if the neural network predict it incorrectly, you use the backpropagation to tell us that you predict wrongly. Then you need to correct your prediction a little bit by updating their weight using gradient descent. And there are actually so many different ways to do language modeling. And the most traditional way, or you can say the earliest way to do that, is use n-gram. It's actually a statistical model. So basically what n-gram does is, let's say if we are using 3 gram, n can be 1 to indefinite. Then let's say if we use 3 gram, then we will have the previous 2 words, and we need to predict the third word. That it's like we have this sentence, but if you use the 3 gram, we will only have the previous 2 content words to predict the next word. This is 3 gram. And also in this model, it doesn't really know which word actually comes first. It doesn't have the sense of word order. That's why its performance is limited. And until context-aware, which is neural network models, getting really popular, n-gram was the dominant model in terms of language modeling. So another one is basically what people are using now mostly, is context-aware language modeling. you can have access to usually very long window of context. In the previous example, we can have the full sentence. Even sometimes we can have the previous sentence. Then we have those sentences as context. Then we need to predict the next word. And just like this, we can have the previous examples here. Then or even the previous sentence or previous sentence to predict this word. And a neural network model will have the sense of order. For example, if you use the recurrent neural networks, you will have the working memory, working cell, like LSTM, they kind of thing. They can memorize what's happening previously. This is what recurrent neural networks can usually do. And in order to predict the next word, because something may be very important is happened many tokens before, you need to memorize that. You need to have access to that. That's why also people use attention mechanism to help the neural network have a longer turn of working memory. And in 2017, the very popular neural network architecture called transformer show up. Basically, it's a combine feed-forward neural network and the attention layer as one transformer block, and you can have many transformer blocks in one transformer model. And people use a transformer to build up a lot of different language models. For example, the most popular one is BERT, which was published by Google, and it achieved a lot of state-of-the-art. And by the way, in a recurrent neural network, I would say it's the first widely adopted context-aware neural network neural language model is ELMO. It's used a lot of LSTMs, or you can say more general, use a lot of RNNs to do the language modeling. And it was popular for around 10 months until the BERT model came out, and it achieved a lot of new state-of-the-art. And also there are also some other adaptation like Roberta is basically they change the training objective of BERT model and also train on a larger data set. And also there's also different way to do the training data mutation, so you can get more training data, which is XLNet. And definitely GPT family, GPT-1, GPT-2, GPT-3, they all are using transformer architecture. And another way to classify language models is you use the direction. If you can access the information from the future. So the one type is called autoregressive language models, and another is called bidirectional ones. So what the autoregressive way is, it's basically you only have access to the previous words. For example, if we want to predict the probability of this token, I always go to that restaurant to have my favorite ice cream. Then in the GPT families actually belong to autoregressive language models. So if you are training a GPT model, you will not have access to these future tokens. Even in the training data, you're supposed to have everything, but because if you have the future tokens in the inference time, for certain tasks, you will not have future tokens. There's some reason they only want to use the autoregressive to train GPT. So in this case, the GPT will only have previous context. I always go to that, which is quite hard to predict restaurant in the training, right? Because you only have the previous context. But if you have the context like in the future context, it's quite easy to predict the words should be restaurant or shop or some other related thing. And this way is called bidirectional language models. You have information from two different directions, backward, forward, in the BERT model and the Roberta and the XLNet. A lot of popular neural network language models are this category, bidirectional. They have so-called bidirectionality, so that the ability to access the full context, to leverage the full context of the sentence document. And this is some history of language models. When first the popular neural language models come up, it was 2017 or 2016. I think it's early 2017 in ICLR conference, and this paper was submitted quite early on. And the first time I read this paper, I think it was 2016 December or something. I was totally scared, totally shocked, because I understand how much potential this language model would have, and indeed it kind of achieved a lot of state-of-the-art in many different NLP tasks. Then few months, 10 months or a year later, Google released and a year later, roughly a few months later, OpenAI released the GPT-1, which have 110 million parameters. And then Google released BERT large model, which we have 340 million parameters. And that time definitely make a sensation, because it also basically Elmer, GPT-1, BERT large, they all achieve the state-of-the-art in the most NLP task at the time they release. So that was definitely almost sensational. And you can see after that, you can see more and more language models are released in a very short period of time. Transformer Elmer, GPT-2. GPT-2 also have 1.5 billion parameters. It was also quite a big thing at that time. And there are also XLNet and Rapporteur. So many different language models got released. And not to mention, NVIDIA trained their super large language model. It's almost 1 billion. It was super mind-blowing at the time. And then Google released their super large language model, which have 11 billion parameters. You can see in 2017, it was just below 100. The largest language model just have 94 million parameters. Then a year later, we have 340 million parameters. Then we have NVIDIA 8 billion parameters Megatron. Then later on, few months later, Google released their 11 billion one. So you can see the speed of increase parameters is definitely insane. And until now, just 2 months back, GPT-3 was released. It contains 175 billion parameters, which is 17 times, almost 17 times larger than previous largest model, which was T5. So you can see how much different GPT-3 is, and also in terms of the performance capability. When you scale GPT, the language model, to 15 times, 17 times, it has totally different behavior beyond our imagination. So that's why I personally think GPT-3 is quite different from T5 and the other previous language model, which I will make some explanation in the next video, because the generalization of GPT-3 is on a different in a different category than these previous language models. But in terms of architecture, GPT-3 is just use exactly the same architecture as GPT-2, and not much different from the other models, apart from autoregressive and the bidirectional. This kind of difference. Okay, so we talk so much about language models, but what can we use that for? So basically, language models, the typical usage of language models in NLP task is to learn a good representation of word, because words are discrete, undifferentiable, which is not good for neural network. And what language models do is they learn a very condensed numerical representation of words, of sentences, of documents, so that you can have once you can have a really good representation, you can perform a lot of tasks much more easily. So for example, if you have a task called sentiment analysis, which is to classify the given sentence is positive sentiment or negative sentiment, then in the traditional way, if you want to build your model from scratch without using language model, you build a task specific model, either it's a neural network model or some other traditional machine learning models. It retrieve the input and predict the output. In the training time, you have input X, you have Y, you learn how to maximize the given input X and predicting the correct Y label. And if you leverage the language models, you have the input still also text, then you go through your language model, and language model will calculate the very good text representation to represent your input text. Then you fit your input text, your text representation to your task specific layers or model. Then model can predict the correct answer. And definitely in practice, language model is maybe transformer architecture. Then you just add one prediction layers on top of very huge transformer architecture, very huge transformer model. Then you can have this whole picture. If you use BERT, then you just need to put 1/5 of neural network to predict the labels that you want to predict. Then during the training time, you can choose to do a backpropagation all the way through and update the language model as well. Or you can choose to fix your language model's weight. You only update your specific layers on top of BERT model. Yeah, this is and when you plug in the language models, super large language model, because they already have seen so much English text, so they can really perform well on the English linguistic task by giving not too many examples. By not too many, I mean tens of thousands or at least 10,000. Still a lot compared to what GPT-3 needs. But this is just the typical way of doing language models, and we usually call this process fine-tuning. We have already the pre-trained language model. We just plug in one prediction layer, and we fine-tune the model to fit the task we want to perform. Let's say sentiment analysis. So that's the rough picture of how we can use language model. Basically, is to use as a text representation, and we fine-tune plug in a prediction layer, then we fine-tune this text representation, also the prediction layer. Yeah, so we have reached the end of today's video. In the next video, we will discuss, can machines learn like humans? We'll compare how machine learns and how humans learn, and how can we narrow the gap between machines learning and the human learning. Next video is part of the GPT-3 explained videos. So if you would like to receive more of them, make sure you subscribe to get notification. And other than that, I will see you in the next video.